Hi everyone, welcome back to my YouTube channel SK Tech. In today's video, we are going to discuss about the queue interface, and we are going to cover what is queue interface, how to create the queue, what is the priority queue. So priority queue is nothing but the implemented class of the queue interface and methods of the priority queue, and also we are going to see some examples. So let's begin. So let's see what is queue interface. So first of all, let's see where the queue interface is reside as part of the collection hierarchy. So first root interface is like iterable, then collection, and then queue. And inside the queue, basically there are couple of the implemented class from the queue interface. The one class is like priority queue. That's what we are going to discuss as part of the today's video. Okay. And this is the list class and array class. So this class internally implemented the queue that we have already discussed, right? So let's see what is queue interface. So basically queue interface extend the collection interface that is as part of the hierarchy. Okay, and it uses the principle of first in first out, like we have seen the stack class in our previous video, right? That is work on the principle of first in last out, but the queue interface is work the principle of first in first out. So what are the elements that we are going to insert inside the queue? When you get the element, it is going to return the first element inserted inside the queue. Next important point that we have to know about the queue interface is like a queue is an ordered list where there is a need to maintain the order of the element. So this is something like in the real time scenario. If you go to the any railway station and you want to get the platform ticket, you need to maintain the queue, right? So maintaining the queue in the sense whichever person is standing in front of the gate, or you can say in front of the window, that person only is going to get the first ticket. So that is the real time scenario or real time example of the queue interface. And as property of the queue interface, a queue is an order list where there is a need to maintain the order of the element. And next important point is like it has a classes like priority queue and array deck basically, but the most famous implementation is that of the priority queue. So in today's video we are going to discuss about the priority queue class only. Okay, so let's see some of the important points that we have to know about the priority queue class. So what is the priority queue? So priority queue class extend the abstract queue and implement the queue interface. So basically it's the implementation of the queue interface only, but internally it also extend the abstract queue. So there are some couple of the feature available as part of the abstract queue, and those feature is going to be available by default to the priority queue. Next point is like as the name suggests, they follow the principle of the priority of the element. So queue means what are the element we are inserting at first going to be written as a first element, means it is working on the principle of first in first out. But there is some priority concept. Using that we can decide the priority of the element, and based on the priority it is going to work. That's why we call this as a priority queue. We know that we follow the first in first out for the queue, but at a time the element need to be processed in terms of their priority, and this is where the priority queue comes into the play. Another property of the priority queue class is like it does not allow the null value to be stored inside it. Like we have seen in case of the array list, linked list, those are the classes it can allow the null value, but priority queue does not allow any null value to be stored. And so we have seen this poll method, right? In case of the stack also the same method is going to be used for the priority queue also to get the element and remove from the queue. And next method is like pick method. This method is also the similar to the stack method, only this method is going to use to display the topmost element without removing the element from the queue. So this is the basic difference that we have seen in our previous video, and these two methods also available inside the priority queue. Okay, now let's see the structure, internal structure, how it is going to be looks like internally as part of the Java concept. So this is how it will be look like. So basically there are two concepts here comes into the picture, rear end and the front end. So basically item has been inserted at the rear end and it removed from the front end. So like when we insert the element, it will go one by one. And what are the element inserted first? Those element will be get it removed from the queue, and that is called the front end. Okay, so this is also called as largest element, and this is called least element. So this is the internal structure formed inside the Java memory. Basically it uses the array concept only, but it maintains the two pointer, rear end and front end. Front end it maintain to get the element, and rear end maintain to insert the element. And because of this pointer, it is able to maintain the first in first out as a priority queue. Okay, now let's see how we can create the priority queue in Java. So first way is like creating the empty priority queue. So basically priority queue also provide couple of the constructor by which we can use it, and we can create the priority queue class. So first one is like creating the empty queue. So this is the default constructor, and this is the generic. So we can use like priority queue, then generic data type, like which kinds of the data we want to insert it, object variable equal to new priority queue, and same data type. And here we are using the default constructor of the priority queue class, and using that we will be able to create the empty priority queue. This is the one way. Another way is like while creating the priority queue with the specified size also. So there is another constructor provided by the priority queue where we can provide the size of the priority queue also. So we can use like priority queue, then data type, then object equal to new priority queue, and then size of the priority queue. If we don't provide any size of the priority queue, Java internally it is going to provide some default size. But let's say we want to provide this size also while creating the priority queue. So this is the way we can create the priority queue and provide the size. Third way is like we can create the priority queue from the collection also, like similar to the array list or linked list. Priority queue we can create with the help of the existing collection also, like this. We can write something like priority queue data type object equal to new priority queue, and then same data type, and here we can provide the list of the collection. So this priority queue is going to create, and also it is going to initialize with the value which we are providing it here as part of the collection list. And the another fourth way we can do it, like since priority queue is the implemented classes of the queue interface, so we will be able to create the priority queue object using the queue interface also, like queue and then generic type, then object equal to new priority queue. So in this way this queue is going to be behave like a priority queue. Since queue can be implemented by the priority queue or array deck, so we can use this and we can create the object of the priority queue. So these are some couple of the way by which we can create the priority queue. Now let's see some of the couple of the operation that we want to perform it. So basically there are couple of the methods available inside the priority queue also, similar to the stack. Okay, but stack we have seen like to insert the element inside the stack we usually use the push method, but inside the queue there is a method called add method. Using that we can add the element. So we are going to perform all this operation in the today's video. That we are going to create the priority queue, we are going to show the initial size, like what are the size of the queue, then adding the element using the add method. Then we are going to perform like displaying the priority queue, displaying the size again after inserting the element, then printing the top element of the priority queue, and then we are going to perform like printing the top element and also remove it. So there are two methods, right, peek and poll. So peek method is going to get the top element from the priority queue, poll method is going to get the element and also it is going to remove it, and then we are going to see displaying the priority queue. So let's go to the IntelliJ IDE and let's perform all this operation one by one. Yeah, so let's create the one priority queue class and main method. Inside that we are going to create the priority queue. So we are going to use the default constructor first. Okay, so how we can do that? Let's type like priority queue, and here we can provide the generic type. Let's provide the integer type and some variable, let's say pq equal to new priority queue. And first operation that we want to perform is like we want to display the default size of the priority queue. So let's print it simply. So pq dot size, and let's write some statement here like default size of priority queue. Okay, let's run this program and see the output. First, what is the default size that is going to return? So if you can see, it is printing the default size as 0, because this size method is going to return the number of the element available inside the pq, not the capacity. Okay, Next operation that we want to perform is like to insert the element. So what is the method to insert the element inside the priority queue? That is nothing but the add method. So add, let's write some element like 101. Let's copy paste and insert some couple of the element. Now let's print this queue. So what is the method to print the queue? So we can simply use this sort method and then we can print it. Let's write some statement also, and let's write like pq list. Okay, let's run this program and see the output. So you can see it is inserted the element like this one by one, but in this way we will not be able to understand like in which order, or while inserting the element which one is the first element that we have inserted it, because priority queue work on the first in first out, right? So let's try to iterate it, and then we will be able to see we have inserted 101 first and then 105 is the last, right? So while getting the element, which element is going to return? Is it going to return the 105 or 101? Because in case of this stack it was returning the last element which was inserted, right? So let's iterate it. How we can iterate it? We can use simple for each loop also, right? And let's try to give the integer type because we are inserting the integer type only, and then pq, and let's print this, and let's write some statement like priority queue, right? Let's run this program and see the output. So if we can see, it is printing like what are the element we inserted first. It has printed first. Okay, now let's try to use the method available inside the priority queue to get the top element. So first operation that we are to perform to get the top element, and we don't want to remove it, and then later on we want to perform get the top element, and also we want to remove it from the priority queue, right? So there are two methods. Let's write some statement to perform those operations. Let's say we want to get the top element, get top element. So pq dot, what is the method? That is nothing but the peek, and we want to get the top element and remove from list. Okay, so after getting the element, let's try to print this, and let's see it is removing or not. And after using this poll method, let's try to print again this queue and see the effect. Okay, now let's this program and see the output. Yeah, so we can see this is the pq list, means priority queue list, and when we get the top element from the list, right? When we get the top element from the let's try to run this program and see the output. Yeah, if you can see, we get the top element from the queue. So which one is the top element which we have inserted inside the queue? That is nothing but the 101. So when we are getting the element, it is returning the first element which was inserted inside the queue, because priority queue work on the first in first out. And after getting the element using the peek operation, we have printed the list, right? And you can see that same element is available, 101 is also available. Then we have performed the get the top element and remove from the list using the poll operation, right? We have got that 101, and after that we have printed the queue. So we can see that 101 has been removed. So basically poll method is used to get the element and remove from the list, but peek method is used to get the element and don't remove from the queue. So this is the basic difference also, and these are the operation. Next operation that we wanted to perform is like displaying the size. Okay, so how we can do that? Displaying the size, what is the method? So method is like size itself. Let's print like size of priority queue, and let's give like pq dot size. And if you want to get the priority of the queue, so it will be simply like if you print this and see the what are the topmost priority. So we have printed already using this priority queue list, right? And if we get the element, let's say priority dot peek, or you can say poll. So we'll see which element is going to be returned. So basically we have already polled the one element, means 101 has been removed and it got returned. Now the priority will be set to the 102. So when we get the again using poll method, it is going to return the 102. So this is how the priority of the element has been assigned. So first in first out. So first we have inserted 101, we have got that 101. Then next element we have inserted 102. So when we use the again poll method, it is going to return the 102. So let's run this program and see the output. Yeah, so if you can see here the way we got like 4 elements, so it is returning size of the priority queue is 4, and again we have poll it. So now it is returning 102 because the next priority assigned to the this element 102. And since we have used poll method, if you print this again priority queue, I mean this list, so it is going to give like, let's run this program and see the output basically. Then if you see the element 102 has been removed. So next priority automatically set to the 103. So when you poll the next element, it is going to return the 103. So this is how the priority of the element has been set by the priority queue. So these are the couple of the operations that we wanted to perform in the today's video, like how to insert the element, how to get the size of the priority queue, how to iterate the priority queue, how to get the priority topmost element, how to get the top element and remove from the list. Now let's see some real-time scenario where the queue actually use. So first is uses of the queue is like multi-programming. So multi-programming means when multiple programs are running in the main memory, it is essential to organize these multiple programs, and these programs are organized as a queue only. So basically in any multi-programming scenario, Java internally uses the queue data structure or queue class to maintain or to organize the programs. Next use of the queue data structure is like networking. So in the network, a queue is used in devices such as a router or a switch. Another application of queue is a mail queue, which is a directory that stores the data and control files for the mail messages. So when you send the mail, basically it put into the queue and one by one it is sending to the user. So this is how it is used inside the networking concept. Next use of the queue is like job scheduling. So in job scheduling also queue data structure or queue class uses. So computer has a task to execute a particular number of jobs that are to be scheduled to be executed one after another. So these jobs are assigned to the processor one by one, which is organized using the queue only. So when there is a requirement to perform the operation one by one, so all those tasks put inside the queue internally and then it is uses one by one. Next is like shared resources. So in case of the shared resources also, queue data structure is very helpful. So queue are used as a waiting list for a single shared resource. So it is like, let's say if resources are shared with the multiple user, so how can we share one by one? So that is nothing but Java internally uses the queue concept and putting all the shared resources inside the queue so that it can be shared one by one for the each user. Okay, now let's see some real-time application of uses the queue. So queue basically uses the ATM both line, like we have seen the example of the ticket counter line, right? There also we should maintain the queue. So these are some real-time scenario where queue actually use. One is like key press sequence on the keyboard. If you press the key, so when you press the key on keyboard, basically it is put it inside the queue, and whatever the key put it first, that queue is going to be executed, because queue is anyway is working with the concept of call first in first out. Next use of the queue data structure is like CPU task scheduling. So in case of the task scheduling kinds of the task also, internally it is uses the queue concept to put all the tasks inside the queue so that it can perform each task one by one, and also it should maintain that what are the tasks we have put it first, that task only should be executed. Next is like waiting time for each customer call at call center. Okay, so that's all for today's video. In next upcoming video, we are going to discuss about the another interface of the collection, that is nothing but the set interface. So stay tuned, we'll meet you soon. Thank you.